Assalamu alaikum warahmatullahi wabarakatuh. This is chapter number 8, electricity. Now we will see how power is transmitted from generating station to the consumer. So we know that electricity is generated at power stations, and these power stations are connected to one another with a network of cables which are known as grids. These power stations are located at places that are very far away from the cities and towns. The power generated at the power generating stations is transmitted to our homes through a national grid transmission system. So, what we have come to know, electricity is generated at power stations, and these power stations are connected to one another with a network of cables. And these cables are called grids, and these power stations are located at places that are very far away from the cities and towns. So power stations are very far away from cities and towns, and the power generated at the power stations is transmitted to our homes through a national grid transmission system. So first is electric power station. At the electric power station, electricity is generated at 11,000 volt or 11 kilovolt potential, and with an alternating frequency of 50 Hz. That is, its polarity at the terminals changes 100 times a second, 50 times plus and 50 times minus. So electricity is generated at electric power stations at 11,000 volt or 11 kilovolt potential, and frequency is alternating frequency of 50 Hz. That is, its polarity at the terminals changes 100 times a second, 50 times plus and 50 times minus. Now the electricity which is generated at the electric power stations is transmitted to grid substations over long distances. At the grid substation, the alternating voltage is increased from 11 kilovolt to 132 kilovolt by using step-up transformer. So at the electric power station, the electricity is 11,000 volt or 11 kilovolt, and when it is transmitted to the grid substation, its voltage is increased from 11 kilovolt to 132 kilovolt by using step-up transformer. Now from the grid substation, the electric power is transmitted to the main substation, and at this substation the alternating voltage is a step down from 132 kilovolt to 33 kilovolt. Now this electric power is transmitted to heavy industries and intermediate substations. Now next is intermediate substation. At this station, the voltage is further stepped down from 33 kilovolt to 11 kilovolt by using step-down transformer. This electric power is transmitted to light industries, that is small industries and city substations. Now, city substations. At this substation, the alternating voltage of electric power is further stepped down from 11 kilovolt to 220 volt by using step down transformer, and this 220 volt electric power enters our homes for daily consumption. So the voltage that reaches our home is of 220 volt. So here we see that electricity is generated at electric power station and the voltage is 11,000 volt or 11 kilovolt. Then when it is transmitted to the grid substation, the voltage is increased from 11 kilovolt to 132 kilovolt by using step-up transformer. Then when this electric power is transmitted to the main substation, the voltage is stepped down from 132 kilovolt to 33 kilovolt. Now this electric power is transmitted to heavy industries and intermediate substations, And at intermediate substation, the voltage is further stepped down from 33 kilovolt to 11 kilovolt by using step down transformer, and this electric power is transmitted to light industries or small industries and city substations. And at the city substation, the alternating voltage of electric power is further stepped down from 11 kilovolt to 220 volt by using step down transformer, and this 220 volt electric power enters a homes for a daily consumption. Now the supply of electricity from city substation to our homes. So State Electricity Board is responsible for the supply of electricity from city substation to our homes, and this is done with the help of overhead wires or by underground cables. So there are three types of wires used. Number one is live wire or phase wire, number two is neutral wire, and number three is earth wire. The live wire carries all the current and it is connected to high voltage supply of 220 volt. The neutral and earth wires are connected together at the city substation. Thus the neutral and earth wires are at the same potential, that is at zero potential. The neutral wire provides the return path to the current. The earth wire passes the current to the earth. So three types of wires are there. One is live wire, other is neutral wire, third is earth wire. And live wire carries all the current, which is of 220 volt. And the neutral and earth wires are at zero potential. The neutral wire provides the return path to the current, and the earth wire passes the current to the earth. Now color coding of live, neutral and earth wires. As we know, all the electrical appliances are having a 3-core flexible cable containing live wire, neutral wire and earth wires. Now each wire is covered with rubber insulation. In order to distinguish live, neutral and earth wires, these rubber insulations are given specific colors. In old convention, the rubber insulation is red for live wire, black for neutral wire and green for earth wire. But according to new internationally accepted convention, brown is for live wire, light blue is for neutral wire and yellow or green is for earth wire. So this is the color coding for live wire, neutral wire and earth wire. Now household distribution of power. The live and neutral wires coming from the electricity poles, they enter the electricity meter in our houses. Live wire is connected to a fuse of high rating, that is 50 amperes, and then to the electricity meter. First it is connected to the fuse, then to the electricity meter. And this fuse is called company fuse or pole fuse. But the neutral wire directly enters the electric meter. Live wire is connected to company fuse, which is also called pole fuse. Then it is connected to the electricity meter, but the neutral wire is directly connected to the electricity meter. The earth wire is connected to the body of the meter. The live wire from the electricity meter is first connected to another fuse. Live wire from the electricity meter is again connected to the fuse, which is called the main fuse, and then to the main switch. And the neutral wire from the electricity meter is directly connected to the main switch. So live wire from the pole is first connected to the company fuse, then to the electricity meter, and from the electricity meter again it is connected to the main fuse, then it is connected to the main switch. But neutral wire is directly connected to the electricity meter, then from the electricity meter it is directly connected to the main switch. Consumption of electrical energy in the houses. As we know, there are many electrical appliances in every house, and these electrical appliances, they consume electrical energy whenever they work. So the amount of electrical energy consumed in a house is measured by a device which is called electric meter, and there is a disc in the electric meter which rotates whenever energy is consumed or an electrical appliance is switched on. The speed of rotation of disc depends on the power consumed, and the number of revolutions of the disc gives the energy consumed. So the total number of revolutions of the disc, they are counted by a special counter of the electric meter, and the total number of revolutions, they can be read from 5 dials seen on the meter, and this reading is called meter reading, and these dials are in the order from right to left in ones, tens, hundreds, thousands and 10,000s. Now to check the electrical energy consumed in a month, what we have to do, we have to check the meter reading in the beginning and at the end of the month, and the difference between these two readings will give the electrical energy consumed in kilowatt hour, which is also known as units. So the cost of electrical energy consumed can be calculated as total cost equals to total kilowatt hour of energy into cost of 1 kilowatt hour of energy. So this consumption of electrical energy depends upon the power of electrical appliances and also on the time for which they are used.